Let us start very important topic, that is the quadratic equation. Before going for quadratic equation, we should know the meaning of quadratic. Quadratic means where we are having the product of two variables. Here, if I go for the quadratic equation which we are dealing with, it will be going to have a same variable, that is x, and it is being multiplied by itself. That is why it is giving the power 2. So when we say about quadratic equation, first I will tell you what is quadratic polynomial. So if I go with that, quadratic polynomial means a polynomial in which we are having ax square bx plus c, means the highest power you can see here, the degree of this polynomial is 2. Why it is 2? Because x is being multiplied by x. So when we say this one is a quadratic polynomial, and when this polynomial is being equated to 0, it becomes an equation. So quadratic equation. So a quadratic equation which has the highest power of the unknown quantity, that is unknown variable, that is here if I am taking this one as that unknown quantity is x. So when this x is having 2, that is the degree is 2. So don't worry about this single term. Here it is having power, this is having power 2, and here we are having one more variable, but the power is 0 when we go for the highest power. So the highest power is 2, then it is known as a quadratic equation. Generally we see the quadratic equations are of two types because the condition is on this particular value, and here one thing is very clear: a should never be equal to 0, because what will happen if a becomes 0? If a becomes 0, this quadratic equation will not be a quadratic, because 0 x square plus bx plus c will give you only bx plus c, which is having the highest power 1. It becomes linear. So to be a quadratic, we know that this a should be not equal to 0. That is why the two conditions are given. And one more thing we have to keep in mind, that they are of two types. One is known as purely quadratic, the other one is attracted quadratic. Means you can say a quadratic one where we are having the highest power 2, but the power 1 and power 0 is also available. We say this one as a pure quadratic. Pure quadratic means the single power term is not there, and we can break this one, because if I am going to get say 3x square plus 4, we can write them in terms of factors, or we can take it to the other side, that is 3x square is equal to minus of 4, then we can have x square to be equal to minus 4 by 3, then we can have x to be equal to square root of minus 4 by 3. And we know that square root of a negative term will give you a complex, that is plus minus iota 2 upon root 3. Means we will be going to get the answer. Suppose if we are having a minus, say 3x square minus of 4 is equal to 0, then we will get 3x square is equal to 4, and x square becomes 4 upon 3, or x will become, I will just take this one as x will become square root of this. So still we will be going to get the answer as plus minus. Means we will be going to get the answer of x much more easily for pure quadratic. And when we say about attracted, we are having different methods of finding the solution. Now let's understand about the roots of a quadratic equation. When we say about a polynomial, polynomial means there we will be going to say that value of x as zeros. But here, that as the polynomial is being converted to equation, we say those zeros as a root. So when we say about roots of a quadratic equation, means the value of the variable x which satisfy the quadratic equation is known as the root of the quadratic equation. Say for example, if I take a quadratic equation like x square, then minus of 3x plus of 2 is equal to 0. So I can go for few values. Say for example, if I take x is equal to 0, I am going to get 0 minus 3 times 0 plus of 2, which is coming out to be 2, which is not equal to 0. So therefore x is equal to 0 is not a root. And the second thing, if I take x is equal to 1, I am going to get 1 square is 1, 3 times 1 plus of 2, that is equal to 1 minus 3 plus of 2, it is coming out to be 0. Since it is equal to the right hand side, that is 0, we can say x is equal to 1 is a root. In the same way, if I go with few more values, say x is equal to 2, I am going to get 2 square, which is 4, and 2 3s are 6, clear, and 2. Now here you can say we are having 4 and 2, 6, 6 minus 6 is 0. So x is equal to 2 is another root. So that means for a quadratic equation, now this is a challenge also, we cannot have more than 2 because that depends on the power. So we can say for a quadratic equation, as the highest degree is 2, highest power is 2, there can be maximum 2 zeros. Or here we are not going to say it as a 0, this is known as a root. So root of quadratic equation here is that value which satisfies the equation, or when we put in place of x, that will make it equal to 0. Understand the method of calculating the zeros, that is solving a quadratic equation. So there are two basic methods we see. One is the factorization method, as we know that we are having a quadratic polynomial. That polynomial is equated to 0, and for finding the roots of a quadratic equation, we go for the first method, which is known as factorization, in which specifically we are having splitting the middle term. That means if we have a quadratic equation, say for example ax square plus bx plus c, it is already written here, where a is not equal to 0. Splitting middle term means I will be going for a into c. I will be breaking this one into two parts. One is a bigger one, other one is a smaller one, and then this sign is of the bigger one, that is plus, and the alternate sign you can put it over there so that the ultimate result is equal to b. In this way you can break it and you can find the roots. Say for example, if I am having then plus 2 and we are having say 5x like this. If this is a quadratic equation, then we will be going to go for this 3 into 2. We are having the product as 6, so their parts are 3 and the other part is 2. One is a bigger one. Then this sign is of the bigger value, means plus, and now we know that we have to add them. This will also be plus, so that the result that I am going to get is 5. So this is 3x square plus of 3x plus of 2x plus 2 is equal to 0. Then this is 3x common, so it is x plus 1, then plus 2 common, x plus 1 is equal to 0. Then we can have this x plus 1 factor common, and we are left with 3x plus 2 is equal to 0. Now this will say that either the first part, because when we say that the product of two numbers is 0, it is sure that one of the two number must be 0. So either x plus 1 is 0, giving you x is equal to minus 2, or 3x plus 2 is equal to 0, giving you 3x is equal to minus of 2, or x is equal to minus 2 by 3. So what we can see that minus 2 and we have minus 2 by 3. So these are the two roots of the quadratic equation. So this is first method, where we say that we are applying factorization method. Now apart from this factorization method, there is one more method we see, which is known as the Sridharacharya formula, or just a quadratic formula. And this quadratic formula is obtained by the method of completion of square, which says that here this has been segregated into two parts. Otherwise we can remember this one as x is equal to minus b plus or minus root of b square minus 4ac upon 2a. Now this is being written into two parts. The first part is taking plus sign, the other one is taking minus sign. So this is the best one, which I say. If you don't know about the factorization method, if you don't know how to split the middle term, quadratic formula is the best formula that we can apply to find the roots of the quadratic equation. Now let's go for one more important part of quadratic equation, that is the discriminant. When we go for quadratic formula, this I'll explain it later on, because when we say that ax square plus bx plus c is equal to 0 is a quadratic equation, then x we have just now understood that by the Sridharacharya formula b square minus 4ac upon 2a. This can be rewritten in a simpler form like x is equal to minus b plus or minus root of d upon 2a, where d is nothing but b square minus 4ac. So, this is known as discriminant. Discriminant means this will discriminate and tell you that what type of roots we will be going to get. That is, before finding the zeros, we can just give a prediction for the roots or the zeros. Clear? And that is the first one. When your discriminant is greater than 0, this is giving you clear indication that we are going to get a real root and distinct roots. Means real means we will not be going to get any complex number. Distinct means different. There will be two answers that we'll be going to get. In the same way, when we say that real and coincident or equal or repeated, then discriminant is equal to 0. This is the second important condition of the discriminant D. And the third one, when we say that the quadratic equation is going to have the complex roots, means discriminant is less than 0. So we can segregate this D to be in two categories. The first category is D greater than or equal to 0. The other category is D less than 0. And this one is there. So we are having no real roots. And here we say real roots, under which we can break it into two formats. If D is greater than 0, means different. And if D is equal to 0, means equal. So this is what we have studied about this. That is, this is known as regarding the nature of the roots. That means discriminant will decide that what will be the nature of the roots. Now the next important part regarding the same discriminant, we have understood about three categories. There are two more categories. One more, the fourth one is when the discriminant is a perfect square. So when we are going to have a perfect square, like if your D is equal to 1, 4, 9, 16, 25, can be any number, but it is a perfect square. Definitely that x, which is minus b plus or minus root of d upon 2a, there will not be any square root, because if I put 1, 4, 9, the square root will get cancelled and we'll be going to get a purely rational root. So at that time we'll be going to say we are going to have a rational number, that is the roots are rational roots. We will not be going to get a square root. Say for example, if I am picking up this 16, so I will be going to get x is equal to minus b plus or minus 4 upon 2a. We will not be going to get a square root. But if we are not getting at a perfect square, that is not a perfect square like any other number apart from this, definitely we will be going to have unequal and irrational numbers, or in the form of surds, that is square root term would be there in these type of roots. So these are the two important formats, that is before going for the discriminant, and if we are finding that it is a perfect square, then we will not be going to get irrational, means if it is a perfect square, we will be going to get rational roots. It can be in fractions, but it will be a rational. But if I say that we are having the discriminant is not a perfect square, so it will be irrational roots. Now let's understand about the relationship between the roots and the coefficient of quadratic equation, same as it was there in polynomials. So when I say that we are having a quadratic equation ax square plus bx plus c is equal to 0, and let there be two roots, that is alpha and beta, then there will be a relationship between the coefficients, as we can say that coefficient of x square is a, coefficient of x is given b, and coefficient, that is the constant, or I'll write this constant, is given c. So with these three numbers we are having the zeros, that is the roots. So alpha plus beta, that is already written, alpha plus beta is the sum which is equal to minus b upon a, and alpha into beta is c upon a. that is the constant term divided by coefficient of x, the constant term that is coefficient of x upon coefficient of x square. So this is very important term that we will be going to use in the quadratic equation. Let me tell you one example. So if I go with, if alpha beta be the roots of any quadratic equation we can take, like 3x square plus 4x plus 5, without finding the roots we can find their sum, that is sum will be equal to minus b upon a, and minus b, as you can see, b here is given 4 upon a means 3. So the sum of the zeros would definitely be minus 4 upon 3, and alpha into beta, that is c upon a, as we can check it, this is 5 upon 3. So this is how we can relate the roots with the coefficients of the quadratic equation. So this is very important result. Let's go now the second important part in this quadratic, that is the already the coefficients we have studied, that is formation of a quadratic equation when the roots are given to you. So when we have the roots, let us say that alpha beta be the roots, and we know that for one root alpha the factor would be x minus alpha, and if the other one is given beta, it is x minus beta, and we are saying that it is a quadratic equation. So these are linear. When two roots are given to you, so the quadratic equation will become x minus alpha and x minus beta. So this is how we can form a quadratic equation. But if I just simplify this one, because when we go for x minus alpha and x minus beta, this is x into, we can write x into x minus alpha and minus beta into x minus alpha, it is equal to 0. So this becomes x square minus of alpha x minus of beta x plus of alpha beta or beta alpha. So this can be written as x square minus of alpha plus beta x plus alpha beta is equal to 0. So what is this alpha plus beta? It is nothing but the sum of the roots, and this is product of the roots. Let's remember this one as a shortcut formula, that is x square minus sx plus p, where s stands for the sum and p stands for the product. Now let's take one more important part of quadratic equation, which is the condition for common roots. If I say that alpha be a common root of the quadratic equation a1 x square plus b1x plus c1 and a2x square plus b2x plus c2, means alpha will be going to satisfy. So this becomes a1 alpha square plus b1 alpha plus c is equal to 0, a2 alpha, I'll write this one as a2 alpha square b2 alpha plus c is equal to 0. By applying that Cramer's rule, or you can say the cross multiplication method, we can write this alpha square alpha and 1 as, that is, this portion will be b1 b2 c1 c2, this is c1 and c2 determinant, and this one is c1 c2 and a1 a2, like this. Opening the determinant, you will get the result, and this portion is a1 a2 b1 b2. Now if you open this one, you will be going to get the value of alpha from here and the value of alpha square from here. Now whatever alpha we are getting from here, now say for example, if I say this is alpha square and some number, let us say capital P, and this is alpha capital Q, and this is 1 upon capital R. So if I say that here alpha we are getting Q upon R, and from here alpha square will be P upon R. Now square of this will be equal to this portion. So definitely if I relate it, now you will be going to get a condition for one of the root to be a common root. Now the next important part is, if both the roots, if roots are common, if both the roots are common, that is both roots are common, so that is very sure that both the quadratic equation are somewhat same, coincident, means the coefficients a1 upon a2, b1 upon b2 and c1 upon c2 all will be equal. Now let's take few questions to understand the roots, that is find the root of the quadratic equation. Very simple question. So here I am just taking the basic method here, that is the factorization method. So I am taking here factorization method. So when I say about the factorization method, it is very clear that we'll be going to split the middle term. So 3 into minus 7. So this is, I don't know how much we are getting, but one number is 7, other number is 3. We know that when we subtract them, we'll get 4. But this one is a bigger one, this one is a smaller one. As I told you, this sign is of the bigger value. So put it minus sign and this becomes plus. So we are having 3x square minus of 7x plus 3x minus 7 is equal to 0. Clearly, x is common, so 3x minus 7. And on the other one, 1 is common, x, 3x minus of 7 is equal to 0. So we are having 3x minus of 7 and x plus 1 is equal to 0. So on solving this one, that is keeping each factor or each of the factor equal to 0, we will get x is equal to 7 upon 2 and minus of 1. So this is one method. The other method that we have is the quadratic formula. So quadratic formula, let us apply that quadratic formula, which says x will be equal to minus b plus or minus root of b square minus of 4ac upon 2a. So which is minus of minus 4, clear, plus minus root of b square means minus 4 square minus of, so minus minus becoming plus, 4 times 3 into minus of 7, that is why this plus is been written, upon 2 into 3. We are going to get 4 plus minus, this becomes 16 plus, and this becomes 7 3 is 21, 21 and 4. We are having 84 divided by 6. So we are getting 4 plus or minus. This portion is 6 and 4. We are having 10, 8, 9 and 10 upon 6, which will give you 4 plus minus 10 divided by 6. So we are going to add them. So 14 upon 6 and we are going to subtract them. That is minus of 6 upon 6. So this is clearly 7 upon 3 and this 7 upon 3. So here actually here by mistake I have written this one. So this is 7 upon 3 and here when we solve this thing, this portion will become minus of 1. So the two answers we are getting, we can apply any of the method in which we are perfect. Clear? If you are having this factorization method, go for that, otherwise quadratic formula is there with us. Let us take one more question, very interesting, and here it's a quadratic equation. Till now we don't know whether it is a quadratic equation. I will be going to simplify this thing. So this becomes x minus 7 is equal to 11 upon 30. Now we have to take the LCM. It's very simple. If I take the LCM, this becomes x minus 7 and this portion becomes x plus 4. With the LCM, x plus 4 and x minus 7, which is equal to 11 upon 30. Now if I just simplify this thing, this portion will become x minus 7 minus x minus of 4 divided by x squared. So this is 4 and minus 7 means minus 3, and when you multiply, this is 28. This is equal to 11 upon 30. Now this will get cancelled. Now if you just cross multiply, so this becomes minus of 11 into 30. That side we have 11 into x square minus 3x minus of 28. So this is 28. Clear? So 28 is there. So this 11 and 11 getting cancelled. So we are having minus of 30, that is equal to x square minus 3x minus of 28. Now you see, we will be going to get a quadratic equation x square minus 3x and we are having minus 28. When this goes to that side, it is plus 2. Very simple. Now this is having a clear cut format of, that is splitting middle term is there. So x square minus of 2x and minus of x plus of 2 is equal to 0. We are having x common, so x minus 2 and minus 1 common, x minus 2 is equal to 0. We are having x minus 2 and x minus 1. So the answers are x is equal to 2 and x is equal to 1. So these are the two zeros, that is the two roots. So 1 and 2, they are the roots of the quadratic equation. So we can apply factorization method or quadratic formula. Let's take one question, which is the roots of the equation. Now this equation is given as a x square plus 1 minus of a square plus 1 x is equal to 0. Now this is not a quadratic format, so let's make it. So ax square plus of a minus of a square plus 1 into x is equal to 0. So we can apply factorization method. It is quite easy now. This is a square plus 1 x. So I'll be simplifying this thing. This becomes minus of a square x minus of x plus of a is equal to 0. Now from these two terms we can see that a and x is common, so left with x minus a, and minus 1 is common, x minus a is equal to 0. So we are having two factors, x minus a is one of the factor and ax minus 1 is the other factor. Clear? Keeping each one equal to 0, when you put this one equal to 0, x is equal to a, the other factor ax minus 1 is equal to 0, ax is equal to 1, x is equal to 1 upon a. So we are having x is equal to a and x is equal to 1 upon a. So the answer is the first one. Let me take one more question, that is the roots of the equation. Now here we are having x square minus of 8x square. This is x to the power 4. Minus 9 is equal to 0. This is not a quadratic, this is biquadratic. But here if I just take this x square to be equal to say a, or I'll just take this one equal to p. Now this becomes p square minus of 8p minus of a is equal to 0. 9. This is 9. Clear? Now when this is there, now this one is a quite interesting quadratic equation where 9 means 9 ones are 9. So we can break this one as p square minus of 9p plus of p minus of 9 is equal to 0. So we are having p common, this is p common, so p minus 9 and plus 1 common, p minus 9 is equal to 0. So p minus 9 is one of the factor and the other factor is p plus 1 is equal to 0. Now putting each factor equal to 0, we will get the zeros. So the first one is p minus 9, that is p minus 9 is equal to 0, so p is equal to 9. The other one is p plus 1 is equal to 0, so p is equal to minus 1, but this p is nothing but x square. So we have x square is equal to 9, so x is equal to plus minus 3. And when we say about this factor, and now this factor is very clear, we are having this one as x square is equal to minus 1, so x is equal to root of minus 1 plus minus, which is nothing but plus minus iota. Isn't it? Complex numbers. So we are having plus minus 3 and plus minus iota. So the answer is B. Now let us take a question. This question says, if 1 upon 2 and 2 upon 3 are the zeros of the quadratic polynomial. Now I have taken a question from polynomials. It doesn't matter that it does not belong to the quadratic equation. Same thing we can make it as a form a quadratic equation in which the roots are given to you. But here this was only for making that the construction of the polynomial or construction of the quadratic equation. If I say that quadratic polynomial, we know that that is x square minus sum of roots or something, we can say zeros also, x, and plus product. That's what we have written. It was x square minus sx plus p. Now here one more thing I will be going to put here, k. Clear that k we will be going to take. Now here if I go for sum means 1 upon 2 plus 2 upon 3. That will give you 6, and this is 3 plus this is 2, 2 to the 4. It is coming out to be 7 upon 6. And if I say about the product means 1 upon 2 and 2 upon 3. On cancellation we can see that it is coming 1 upon 3. Now this equation will become x square, that is x, k and x square minus of sum means 7 upon 6 x and product 1 upon 3. Now if I take the LCM will be of 6. So I'll take the LCM of 6 and this becomes 6x square minus of 7x plus 6 and 3 we are having 2 here. Now this is k. Now if I just make it a quadratic equation, or if I make this one as a polynomial, then we have to take the value of k as 6 so that the denominator will get cancelled. So finally we can say that the polynomial is 6x square minus of 7x plus 2. If I say that is an equation, I will be going to put it equal to 0. Clear? So this is how we construct or form a quadratic equation or quadratic polynomial. Now let me take one more question to make this concept much more clearer. That is, the number of roots of the quadratic equation, where we are having the quadratic equation x is equal to 8 sine square theta minus 6 8 sec square theta minus 6 sec theta plus 1 is equal to 0. Now if I just go for that sec theta, if I take it equal to x, then I will be going to have 8x square minus 6x plus 1 is equal to 0. Now if I just go for the factorization method, here we are having 8 ones are 8, so that is 4 into 2, and 4 and 2 will be making 6. So this is 8x square minus 4x minus 2x plus 1 is equal to 0. So we can have this 4x common, it is 2x minus of 1, then this is minus 1 common, so I will write this one as 2x minus 1 as a factor. Now this 2x minus 1 as a factor, the other one is 4x minus 1 is equal to 0. This will give you two answers. One is x is equal to half, the other one is x is equal to 1 upon 4. X is nothing but sec theta. So sec theta is 1 upon 2. We know that theta will be going to give you two answers, because sec is positive in the, you can say, in the first quadrant. So first quadrant we will be going to say that in the first quadrant the answer will be sec. Here if I will be writing this one as sec theta, this is for cos. If I go with cos, cos is giving you the answer 1 upon 2 at 60 degree, that is pi by 3. So same is with this one. So we are having this one as 1 upon 2. So sec value 1 upon 2, actually if I go with the value of this sec, this will not lie, because the value of sec 0 is 1. And if I go with sec 90, it is not defined. And we know that when I go with the definition of sec, as cos is having the graph somewhat like this, the values are in between minus 1 and 1, minus 1 and 1. Then we will be going to say that sec will be going to have the values on the upper side. That means sec will not be going to have any value in between. That means if I am saying that sec theta is equal to half, it will not give you any answer, because the value of sec, or we can say that the range is always from minus infinity to minus 1 and from 1 to infinity. So that is the range of the sec. So sec is not going to give you the answer half. In the same way, sec will give you the answer as that is between the range of minus 1 to 1. So if I go with this quadratic equation, as far as your x is concerned, this is okay. But if I equate it to sec theta, this will not be going to have any answer. So the answer is 0. Now let us take one more question, that is the roots of the equation. Now the equation is given somewhat complicated. It is containing square roots. So 3x plus 1 with plus 1 is equal to root of x. Now to simplify or to get the roots of these equations, I will be taking one of the term which is containing square root on the other side. That is, already x is there on that side, so I am taking that one on that side, and let us square it. Now if you do the squaring part, this squaring part will give you the answer 3x plus 1, and on this side if I go with the whole square, this is root x square x minus 2 root of x plus of 1. Now I will be going to take this 2 root of x on one side, that is, we can keep it on the other side also, and let's bring everything to this side. So this is 2x and this is going to cancel. So we are having minus of 2 root of x. Again I will go with the squaring, but before that I will cancel out this 2, and again if I go with the squaring part, I am going to get x square is equal to only x. Clear? Now we can take this x square and x on this side, and generally students used to cancel that x, but we will not be going to do. So here we can say the answer we are getting, x is equal to 0 and x is equal to 1. So these are the two answers, but I have to just confirm it whether you are giving the same answer. If I put that 0 here, so we will be going to get 0, this term becomes 0, it is root of 1 plus 1, that is equal to 2, and that is equal to is not equal to root of 0 means 0. So this is not satisfying the given condition. So I'll go with the other choice, because for x is equal to 1 I am having here 3 plus 1 4, root of 4 is 2, 2 plus 1. Sorry, here we are having, if I put x is equal to 1, I am going to get this value as you can say x is equal to 1, we are having 3 plus 1 which is equal to 4. So 4 plus 1, that is root of 4, that is 2 plus 1, so our answer is 3. On the other side, if I put the value of x, it is equal to 1. So if I just say that whether they are satisfying the equation, so here we can say for 0, because here the answer that we were getting is actually not giving you the option. So here we can say we are not having any of the answer. So none are the roots.